we forgot to check the true tone setting. So if it flickers now, it's my bad. It's not this. Thank you so much for having me, and thanks to all great speakers and to the conference people who just put together this amazing conference. I'm honored to be on stage, and I'm going to talk for 32 minutes about best practices in SDK development and how to build a great developer experience. Not only for the SDK developers who are going to use your SDK, but for you as well as an SDK developer. So if you have any talks, submit it to Adam. If you have any questions, you can scan this QR code, and hopefully we can get to them at the end of this talk. But first, the vanity slide. Me. Who am I? Who am I talking here about SDKs? Well, I'm Daniel. I'm from Stockholm, Sweden. I grew up in a small town in Sweden, so that's a big step, moving to the big city and working with app development. So I just want to make a quick recap of the last 40 years and how I ended up on this stage. So Sweden, amazing. For many, many months, 4 months every year, it's amazing. I would dare to say the best country in the world, perhaps. But then we have November, December, January, February, March, and April, and then it's pretty cold, dark, gloomy, and wet. And as a kid growing up in the 80s, I asked ChatGPT, like, can you visualize my upbringing? And I think it nailed it pretty well. So you tended to spend a lot of time indoors, playing with toys, inventing your own board games, and be completely disconnected from reality and the world whatsoever, right? But then in the mid-90s, I didn't play with toys then, but something happened that changed quite a lot. Something came around that made it possible to be connected to the world inside. Back then, Sweden had a great incentive, hem-PCn, the home PC, believe it or not, and that made it possible for families to get a PC and an internet connection for a very affordable price. So we watched the images load line by line in the confine of our own home. And back then, the internet was a physical place. So you went to the internet, you sat down by the internet, you waited by the internet, and then when you were done waiting, you left the internet and went back to reality. Quite a different time. So I love the internet, started developing web applications, web pages in HTML and CSS. I don't know if I never got around to that. Build websites, applied to the university for a computer science degree. It was amazing, and then it was time to go out into the real world and build stuff for the internet. Then the internet had changed a little bit. It had become mobile, it got legs. Suddenly you could carry the internet around in your pocket. It wasn't as lightning fast as it is now, but my first job was actually to build mobile applications for a platform that everyone in here knows and loves. It's called the Pocket PC, an amazing mobile platform. It was okay, kind of low on memory. So I did this for a few years, did backend development, web development, built web APIs, amazing. But then, of course, this is an iOS conference, of course the iPhone. But you know, much like everyone else, I guess, in here, when I saw this for the first time, it was like, kind of makes sense, right? This is probably my future for the next 20 years. But it took a while to get started. But when I started building applications, of course, I realized that it's probably good to have a bit of code reuse and put things in a CocoaPod or a Carthage module or perhaps a Swift package. That's an amazing thing. So that led me into SDKs. But before we start talking about SDKs and what that is, what is it? It stands for Software Development Kit. I think most of you know what that is. My definition of it, I was supposed to bring tomatoes if you disagree with me, but my definition is that it's a complete set of tools to let you build software for a platform or a system. So one example is the iOS SDK, which has simulators, libraries, APIs, documentation. That's an SDK. But this talk, it's a Swift package, come on. Everything I talk about here applies to creating a basic Swift package as well. And it's also safe for work, so you can take whatever I bring here today and apply it to perhaps modularize the code at work as well. So, SDKs. Thank you, Daniel. Breathe. Nice. SDKs, I've built quite a few of them. I have about 20 plus open source projects active on GitHub. They're by no means SDKs, they're Swift packages, but I tend to them very much like I do with my commercial software. So I have created closed source SDKs as well, which I have commercial licenses for. And I'm going to focus a little bit on this throughout this talk. This is not a sales pitch, but I'm going to do a little bit of a sales pitch. This is an SDK called KeyboardKit. It lets you build custom keyboards, and we are going to focus on the autocomplete feature. If you want a sticker, and if you want to see how a custom keyboard can change your life, come up to me afterwards, grab a sticker, and then if you contact me later and want to get on the pro plan, you can just show me the sticker, and I will give you a nice discount. So I've been doing this for 9 years now, keyboards for 9 years. And it's amazing. It started off as an open source project, now it's closed source. It's free, it has commercializations. It's great. So let's talk about SDKs and how to build a great developer experience through best practices. So this is a huge topic, right? But 3 quick bullets. An SDK should aim for delight in the same way as your apps do, right? An SDK, the user interface for your developers should be great and make sense. Developers should be able to trust your SDK so it doesn't break between versions and over time, right? And if your API has to break, take the user around on a journey. Take care of your users. It's very important. So I could talk about each of this box for hours. I just have 27 minutes left. 23 minutes left. Oh, let's get started. So we are going to focus on these 5 areas, which are more code and craftsmanship centered, right? We're going to talk about API design, system design, testing, documentation, and versioning. And we're going to start with API design. So the API design is the user interface of your SDK. It's the thing that the users are going to interact with to use your SDK, right? So it's very important that your API design guides your users to the most important part and guides them around using the SDK. So we're going to take a look at 3 ways to do that. This is by no means an exhaustive description, right? There's so much more, but we're going to take a look at access control first. Access control is the way that you intentionally expose members of your SDKs to your users. So say that you are building a great SDK, and you have a great SDK feature. If you ship it like this in a Swift package, users will not be able to see it, and the documentation will not pick it up, because all types in a Swift package are internal by default. So what you need to do is to explicitly mark the stuff you want to expose as public, right? So this is a little bit different compared to if you if you build an app and just have everything internal and you can access everything. With SDKs, you need to expose it, and if you want people to be able to inherit the class, you need to mark it as open. And the same goes for the things inside as well. So you need to use access modifiers to design your intended public API. So say that we open up this type, we make it public. If we were to ship this, people would be able to see the type, but they wouldn't be able to create an instance of it or use the things inside. Type members are also internal by default. So you need to apply intentional access modifiers to make the type do what you want it to do when your users use it. So in this case, people can access it, they can calculate the meaning of life, internal joke, or internal, it's a joke, of course, but they cannot access the meaning of life, property. So the key takeaway here, though, is that when you create your first SDK, you're like, yeah, Daniel said we're going to have to mark everything as public. Do not do that. Do not overexpose type members, because that's going to make the SDK very hard to maintain over time. So pick the things that people should use, make them public. Design your API. And when it comes to the API surface area, that's also a very important thing to maintain. So the API surface area is the collection of all root level types in your API. So when I started building KeyboardKit, the autocomplete feature, the toolbar, just consisted of a few types. And if a user comes and imports keyboard kit and starts typing autocomplete and it gets 4 types, it's pretty obvious. I think it's worthy of a green check mark, right? But if your SDK grows over time, like mine did, and you don't put care into it, suddenly you can find yourself with a feature that has like 40, 50 types exposed at the API root level. And that's going to be the death of your public API. People are not going to be able to find a way around it. So you need to manage the API surface area and avoid bloating it with too many types. One way to do this is by using namespaces. And there are different ways of doing this. If you have a Swift package, you can, with just one package, with just one library inside, you can use structs and enums and nest types within them to create, structures. If your package can contain multiple products, then you can use multiple libraries, and each library can serve as a namespace. Personally, I find that to be a bit more confusing and hard to use multi-product packages, but that's because I'm slow. You can also extract unrelated types. So for instance, when I started building the license engine for KeyboardKit, the Pro version that is protected by commercial license, after a while I realized that the license engine didn't really belong, right, in this SDK. So I extracted it into its own thing. So we are going to take a look at structs because it's the most easiest thing to cover today. So imagine me staring at this bag of code, right? So many types. I knew that I needed to do something. So too many types like this, the API is going to be unusable. So what you can do is create a struct and use it to nest the types within it. So now we have an autocomplete namespace with a bunch of types inside. And of course, every type is probably going to go into its own file and everything. But if you place it in a public extension, everything inside the public extension is going to be also public by default. So now we can remove that if we want. We also now already have the autocomplete name in the namespace. We can remove it from the type name. But that's a matter of choice. Some people prefer to keep the full name for discoverability. What I found when I did this with KeyboardKit is that suddenly you just have an API that consists of namespaces. And to me, at that time, it wasn't the best choice. So what I chose to do was a different approach. That I have my namespace. I promote some types to be top-level types, the types that are most important for people, right? And then I nest everything else inside an extension. I don't have a green check mark because this is highly subjective, but it's something that worked for me. The key takeaway is to design your namespaces so it makes sense for your SDK and guide users to the most important part. So while the API design is the work you put in to give users a great experience, the system design is the work you put in to give yourself a nice future so you don't have to work with breaking changes and stuff over time. So the system design should be stable, but yet, in the case of KeyboardKit at least, it needs to be customizable. So people should be able to customize the software, but in a very controlled way. So we're going to take a look at 2 topics here. How to use types instead of values to create stability, and how to use enums and structs in different ways to provide customizations. So types over values. When I started building the autocomplete service, it was very basic. It didn't really look like this, but more or less like this. You have a protocol, people can create their own services, or I provide a standard service for them. People can toggle autocomplete on and off, and they can also call the autocomplete function with a string, and in return they get a list of suggestions back, right? The suggestions you see in the top toolbar. When I released this, customers started coming back to me like, we want to be able to control more stuff. Perhaps we want to be able to toggle autocorrect on and off. And I looked at the protocol and realized that the suggestions you get are not really just words, right? Some are wrapped in quotation marks, some have a white border. They have contextual information as well. So I needed to change this. And every time you change a protocol in your SDK, that's a breaking change. So that's a big warning. If you find yourself breaking your design at all times, you need to perhaps design things a little bit different. So in this case, I think the key takeaway is to avoid designing with primitive types. Do not not use it, but avoid using it where it really matters, right? because it's going to be very brittle in the future. So a better way, if we go back to this example, instead of having the two configuration properties, perhaps we can have a struct or something instead, like a settings type. This type can be extended over time and contain more contextual information without breaking the protocol. And instead of passing in a text, perhaps we need to pass in more information, like the current locale or whatever you want. So perhaps we want to send in a request instead. Oh, by the way, the settings things, that might just be an implementation detail. Perhaps it doesn't even need to go into the protocol. And then finally, when we get a result back, perhaps not just return an array of suggestions. Perhaps we want to return more stuff. KeyboardKit returns more predictions, next word predictions, next character predictions, etc. So the result type can now be extended over time without affecting the protocol. And if we look at this protocol, we send a request and we get a response back. It looks very much like a web request. So we can just, perhaps design it to be a sync. So if we design our entire system to be a sync, it can scale more better in the future. So I think this is worthy of a green check mark. So prefer to design with types. I would say that would be my key takeaway here. When it comes to enums and structs, I tend to use enums and structs differently when I build apps from when I build SDKs. I use them in very specific ways when I build SDKs. So in an SDK, I use enums to represent a closed set of options, right? So the SDK can handle a well-defined set of options, fixed options. We can handle every possible case. And users have easy customizations by picking from options. So in this case, the autocomplete suggestion type, the type of the words we see in the toolbar, that's an enum. And that means that we can extend that type with contextual information, like should this suggestion be applied when we tap a word delimiter like space? Autocorrect should, the rest shouldn't be. We can also design the rest of the API to use SDK to use this information as well. So the background color in the autocomplete toolbar should be white for autocorrections and transparent for others. So enums are great for a closed set of options. Structs, on the other hand, are great for customizable values. So in Swift, we see this with button types, with styles, with configuration values. And it's great to represent open-ended data structures. So the SDK can provide standard styles, standard configurations, for instance, but users can customize the values inside these types. And the SDK doesn't really need to care about the values, because if the user provides an incorrect value, they're going to know about it. If they provide an incorrect URL or a color, they're going to see the result, and it's going to be on them, right? So one example could be the autocomplete toolbar style, which contains a lot of colors, fonts, etc. The SDK can deliver a standard style, which is applied by default. But then users can just provide their own overrides as well. So structs, great for customizations in a more extensive way than using enums in an SDK. When it comes to testing, it's very important, of course, to have unit tests in place and integrations tests and regression tests, perhaps. But I would also quickly advocate to use design tests to test your API design. I've made this mistake many, many times. So if we're going to take a look at one code example here, let's say that we have this type. We're going to start building our standard autocomplete service implementation. So this is a very basic thing. Of course, it's not real code, but it has an internal suggestion list, and then the perform autocomplete function ignores the request and just maps this internal value to suggestions. And we test it. I don't know why, because it's just dummy code, but we test it, and we see that if we change the internal value, we change the output. Very easy. The only reason we can do this is because we have a testable import. And that is something that is very dangerous, and that made me ship broken code many times. Because if you change the testable import, if users use this without the testable import, the code is going to break. because the public initializer, there is no public initializer here. So you made the type public, you made the functionality public, everything is public and great, but the users cannot create an instance of this. And if that is your intention, then the SDK is broken. So, yeah, let's see. If you just add a public initializer, the problem goes away and everyone is happy. So that would be a strong recommendation from my side, to test your public API. Otherwise, it's easy to ship broken code. We're quickly going to go through the documentation part. I think you all know about documentation. You use software on a daily basis. One thing that is really nice to have is a good README file. So the README file on GitHub can guide users in a quick way, while you can use docc to extend the documentation. So the main README file, very basic. You write it in Markdown. You can have some branding. You can show some installation and getting started guides. You can sell your features. But docc takes it one step further. So in docc, you start with a main article, and that's basically going to be the same as the main README file. It's also written in Markdown, but it is a superset of Markdown where you can also have docc-specific widgets. You can have tabs, columns, a bunch of additional tools, and you can link to types within your SDK. So this is really good. Everything that is public in your SDK is exposed to docc. And you can document your source code by using the 3/ or /* syntax to just document all your public types. And that is also going to result in this nice article page that really can help your users get started using your software. But too much code documentation can also, bloat the code file and just make, where's the source code? It's just text and Markdown everywhere, right? So if you want to extract some, you can use articles to extract some documentation. So articles can be tied to a certain type, but it can also be standalone. And if you create articles, you write Markdown, you can use the same tools as in the code documentation and the main article, and it's also going to render in a beautiful. This is very boring, sorry for that, but you can have images, and you can have tabs, and you can have screenshots. The world is your playground, right? So use articles. So docc is very, very, very good for documentation. But if there's one key takeaway, if you build a big SDK, I would strongly suggest that you manually handle topics within docc. Because if you do not, in KeyboardKit, there is so many types, right? And docc is just going to take all the public types in a shovel and just throw it into the main article and list them in the bottom of the main file. So can you imagine having hundreds of types, and at the end of the list, you have a list of articles, protocols, and classes, unstructured? It's horrible. So what you can do, I created like an article for each feature. So autocomplete has a feature, has an article, dictation has an article, and then all of those articles use a manual topic setting that I place in the bottom. It has to be called topics, and it has to be in the second headline level. So there I just link to all the types that I think make sense for that feature. And then as a result, the main file is going to be clean with just the topics you selected for the main file, and the rest of the articles are going to link to the rest. And that's great documentation. So if you haven't checked out docc, use it. You can also convert the documentation to HTML and host it on GitHub pages for free. Great. Finally, the final topic with 6 minutes to go, versioning. So now you've done the groundwork, right? You have created a great API for your users. The SDK is stable and future-proof. And you have great documentation on the internet. So you can sit in your hem-PC and read your documentation. Everything is perfect. Now you just need a version strategy. That's the final piece of the puzzle. So it's very important when you start building an SDK that you're more serious with, that you pick a version strategy before releasing it to the world. So my version strategy is, when I start with the 0.1, the 0.2, the 0.3, I allow myself to have breaking changes between the minor versions. But as soon as I hit the first major version, that's when I switch over to semantic versioning. And we're going to take a look at semantic versioning first, soon. But first, we're going to talk a little bit about breaking changes. And then we're going to take a look at deprecations. So breaking changes. I thought we agreed that an SDK shouldn't have breaking changes. That's a bad thing, right? Well, an SDK, of course, if it lives for a couple of years, it's going to have a lot of reasons to break. So you're going to have breaking changes happening. It's going to be forced upon you, or it's going to be your intended choice. But when you want to break something, semantic versioning is a really good thing. So semantic versioning works a little bit different when you build apps compared to when you build SDKs. When you build apps, you redesign the first page, the home page of the home screen of your app. You change the tint color, and suddenly it looks so much nicer. This is no longer a 4.5. This is a 5.0, right? It's very subjective. When it comes to SDKs, it's not that subjective. If you commit to semantic versioning, the 1.0, the 2.0, the main versions, the major version numbers, is the only place where you're allowed, where you're expected to have breaking changes. The minor version is a bump when you're making something that is a little bit more a source of pride. You create a new feature, or you make a big change that feels good in your belly. Bump it up a minor version, but don't break things, right? And finally, we have the patch version. That's for small changes, fixes, and tweaks. And those can be very frequent and bug fix often and well, right? But this semantic versioning, if you commit to it, first of all, great, you're a responsible SDK vendor. But it's also like a promise to your users. It's actually a contract. You promise your users that you are going to manage breaking changes for them and guide them through. Whenever things break, you're going to hold their hand and walk them through the changes. So one way that you can do this is by using deprecations. So deprecations is a great tool in Swift. And the deprecation dance goes something like this. You look at something in your code base and it's like, oh, this needs to be renamed, or oof, this needs to be removed, or Apple did something and now the world broke. So if you need to change something, and if you have the possibility, a good way is to deprecate the things you want to change well ahead of time. So if you know that you want to remove this thing today, you will have to wait. Deprecate it today. Instruct your users how to handle this change. Take that deprecated code and put it far away in another folder somewhere, but make sure that it works and that it's stable. And then finally, when it's time to perform a major version bump, that's when you can remove it. But it's very common for deprecated code to live on for a long period of time, like in SwiftUI, for instance, where you have deprecations living for years after years, right? So we're going to take a quick look, and then it's time for questions. If we return to this standard, it's a joke to call it standard autocomplete service. This is a stub of something, but it's a good example. Let's say that we look at this type, standard autocomplete service, and it lives inside the autocomplete namespace. And we are the kind of people who prefer short names instead of long names. Perhaps we want to change this. I want this to be called standard service because that's my style. If you change it like this and you have users using your SDK and they import your 8.2.3 patch version with this change in it, their world is going to explode, right? And why does it explode? Because now suddenly the standard autocomplete service type is no longer around, it's gone. You removed it from them. You renamed it, sure, it's still there, but their code breaks. So it's not an excuse, right? So if you would fix this by changing the unit tests and then be done with it, that would be a pretty bad fix, because that only fixes it for you while your users are crying and tearing their hair off their heads, right? So a better way to do this is to create a type alias with the same name as the old type, have it point to the new type, and if you do, your code is going to be fixed. But this is not really a good fix, because now we just have two ways to access the same type. The point with this type alias is that now you can annotate this with a deprecation attribute. And if it's just a renaming, if you rename a type or a function or a property, you can use the renamed keyword. If you use the renamed keyword, the users are going to see this warning with a nice fix button that they can tap and just automatically make the change. But if the change is a bit more complex, for instance, we realize that this standard autocomplete services crap is just made for this presentation. It makes no sense to have it around, and you want to remove it, then you can use the message attribute and say that this class is going to be removed. You should probably do something else with your life than using code that was done for a talk in SwiftLeeds, right? And if you do it like this, people are going to get the same warning but without the fix button. But at least you've taken their hand, you've given them some guidance in the world of breaking changes. So time is up. Time is up. I could stand here talking for hours. I'm sorry that I have to leave. But the final takeaway, establish and communicate a versioning strategy and use deprecations to manage breaking changes. Breathe. SDK development is a lot of fun. If you create a package and people use it and people love it, it's the best feeling in the world. It's not the best feeling in the world when they reach out to you with stuff breaking and things not working. But if you take care of doing your best to guide them through years and versions, they're probably going to stay happy and even forgive an ever so slight mistake every once in a while. And hopefully you can also stay productive over years and version numbers. Thank you so much.